Have you ever seen something disappear right before your very eyes? A magician pulls a rabbit out of a hat, and then poof, it's gone. But what if I told you the universe performs a much bigger, much more mysterious vanishing act? Imagine a giant ball of ice rock bigger than a mountain hurtling through space. It travels for thousands of years, maybe even millions of years. It gets closer and closer to our sun, putting on a spectacular show in the sky. And then, just as it rounds our star, it vanishes, gone without a trace. How can a comet, a massive celestial object, simply disappear? It's one of the strangest and most baffling mysteries in our solar system. This isn't science fiction, it's a real cosmic puzzle that has stumped astronomers for decades. These disappearing comets are like celestial ghosts. We see them coming, we track their path, we predict where they should be, but when we look for them on the other side of the sun, there's nothing there. It's as if they flew into a hidden cosmic trapdoor. What powerful force could obliterate a mountain of ice and dust in hours? Is it the sun's incredible heat, its immense gravity, or something else we haven't discovered yet? The story of these lost comets is a journey into the heart of our solar system's most extreme environment. Think about it, we can send rovers to Mars probes to the edge of the solar system. We can peer into galaxies billions of light years away. Yet something happening in our own backyard remains a profound mystery. The disappearance of a comet is more than a lost object. It's a clue. It's the universe leaving us a little breadcrumb trail, inviting us to follow it and uncover some of its deepest secrets. Each missing comet is a chance to learn about the raw power of stars and the fragile nature of icy wanderers. A reminder that strange phenomena still await understanding. So let's become cosmic detectives, put on our thinking caps, and dive into this incredible mystery together. To solve the mystery of the vanishing comet, we first need to know what a comet is. Forget what you might see in cartoons. They aren't just shiny stars with a tail. A comet is more like a giant, dirty snowball. Seriously, they are made of ice, dust, and frozen gases. Carbon dioxide, methane, ammonia. Think of it as a cosmic slushy packed with rocks and dirt. These ingredients are leftovers from the very beginning of our solar system about 4.6 billion years ago. That means comets are like ancient time capsules, carrying secrets about what our solar system was like when it was just a baby. They are some of the oldest, most pristine objects we can study. These dirty snowballs don't just float around anywhere. Most of them live in two very distant, very cold places in our solar system. Kuiper Belt, a donut-shaped region beyond the orbit of Neptune. Oort cloud, a giant spherical shell that surrounds the entire solar system. It's incredibly far away, so far that it could take light over a year to cross it. Comets can hang out in these cold, dark regions for billions of years, just waiting. They are in a deep freeze, perfectly preserved until something gives them a little nudge. So what makes a comet start its long journey toward the sun? Usually it's a gravitational push or pull. Maybe a passing star jostles the Oort cloud. Maybe two comets in the Kuiper Belt bump into each other. Whatever the cause, this little nudge is enough to send a comet falling out of its comfortable, cold home into a new path. An orbit that takes it looping toward the inner solar system. This journey can take thousands or even millions of years. For all that time, the comet is just a dark, frozen lump tumbling silently through the blackness of space. It's completely invisible to us on Earth. But as the comet gets closer to the sun, something magical begins to happen. The silent, frozen traveler starts to wake up. The sun's warmth begins to heat up the comet's icy surface. This is where the real show begins. The journey from the cold, outer darkness into the bright, warm inner solar system is a dramatic transformation. It's a trip that will change the comet forever, and for some unlucky comets, it will be their very last adventure. The quiet life is over, and a dangerous, fiery dance with a star is about to begin. As our dirty snowball gets closer to the sun, around the orbit of Jupiter, it starts to feel the heat. The sun's energy is like a giant hairdryer pointed right at the comet. The ice on the surface doesn't just melt, it turns directly into a gas. Sublimation. This releases the dust and rock trapped inside the ice. Gas and dust form a big, fuzzy cloud around the comet's solid center. The nucleus. That cloud is the coma. The coma can grow enormous, sometimes bigger than Earth. It's the first sign the comet is coming to life. The sun also blows a stream of charged particles, the solar wind. The solar wind acts like a powerful fan, pushing gas and dust away. That creates the comet's tails. Tails, plural. Most comets have two, dust tail, tiny rock and dust particles from the ice. Wide, curved, yellowish white, it reflects sunlight. It follows the comet's orbital path like breadcrumbs. Ion tail, gas tail. Made of gases frozen in the nucleus. Sun's UV knocks off electrons. The gases become ionized. Charged particles are pushed straight away by the solar wind's magnetic field. Ion tail is thinner, straighter, often glowing blue. It always points directly away from the sun, like a cosmic windsock. As the comet races toward the sun, it puts on an incredible light show. It sheds mass to make tails that stretch millions of kilometers. Spectacular, but the comet is losing part of itself. Each trip around the sun strips more ice and dust, like a melting ice cube on a hot day. The closer it gets, the faster it loses material. That's what makes comets dynamic and exciting, and dangerously ephemeral. Now imagine our comet getting really close to the sun. We're not talking about Earth's distance anymore, we're talking about comets that fly so close they almost skim the sun's surface. These are called sun-grazing comets or sun grazers. For these comets, the sun isn't just a gentle source of warmth, it's a terrifying, all-powerful monster. The temperatures can soar to millions of degrees, hot enough to vaporize rock. The radiation is so intense it can break molecules apart in an instant. This is the ultimate cosmic trial by fire, and not every comet is strong enough to survive it. It's this transformation that gives a comet its beauty, but it's also what seals its fate. The quiet life is over, and a dangerous, fiery dance with a star is about to begin. The history of astronomy is filled with ghost stories of comets that were seen once and then never again. One of the earliest and most famous cases is Lexell's comet, discovered in 1770. This comet made one of the closest known approaches to Earth, coming within about 2.2 million kilometers. It was bright and easy to see. Astronomers calculated its orbit and predicted it would return in about 5.5 years. But it never did. It was gone. Later calculations showed that its close pass by Jupiter had completely changed its orbit, flinging it out of the inner solar system, perhaps forever. It was a cosmic disappearing act caused by a gravitational slingshot. Another classic mystery is Biela's comet, discovered in 1772. This comet was a periodic comet, meaning it had a regular orbit that brought it back every 6.6 years. It was seen several times right on schedule. But in 1846, observers were shocked to see that it had split in two. There were two comets flying side by side. When it was due to return in 1852, the two pieces were even further apart. And after that, nothing. Biela's comet was never seen again. It seems the comet simply disintegrated. Years later in 1872, Earth passed through the comet's old path and was treated to spectacular meteor showers. In 1885, Earth passed through again more meteor showers. We were flying through the dusty remains of the lost comet. These aren't just old stories from a time with less powerful telescopes. Even in the modern era, comets go missing. We have powerful space telescopes like the Solar and Heliospheric Observatory, or SOHO, that watch the sun 24/7. SOHO has discovered thousands of sun-grazing comets, most of them tiny fragments from a larger parent comet that broke up long ago. We see these little comets dive toward the sun day after day. Most of them are completely vaporized. We see them go in, but they never come out. They are consumed by the sun's fiery furnace, offering a constant real-time example of how comets can and do disappear. But every now and then a larger, more promising comet comes along, and its disappearance becomes a major event. These are the comets that are predicted to survive their trip around the sun. They are big enough, and their trajectory seems safe enough. Astronomers get excited, the world watches, and we all wait for the comet to emerge from behind the sun, brighter than ever. But sometimes the universe has other plans. The comet is gone and a new mystery is born. We started with a simple question: can a comet really vanish? And we found that the answer is a resounding yes. Vaporized by heat, ripped apart by gravity, thrown out of the solar system entirely, the story of a vanishing comet is a story of incredible power, cosmic violence, and enduring mystery. It's a reminder that even in our own solar system there are places of extreme danger and places of beauty where the laws of physics are pushed to their limits. The universe is not a quiet, peaceful place. It's a dynamic, ever-changing stage for the most spectacular show in existence. From the icy depths of the Oort cloud to the fiery furnace of the sun, we've followed these cosmic snowballs on their incredible journeys. We've seen how they come to life, painting the sky with their beautiful tails, and we've seen how some of them meet their dramatic end, disappearing in a final, ghostly whisper. Each lost comet, from Biela to Ison, isn't just a failure, it's a lesson. It teaches us about the building blocks of our solar system and the raw, untamed power of our own star. It shows us that even an object as big as a mountain can be erased from existence in the blink of a cosmic eye. The universe is filled with an infinite number of these stories, an endless supply of mysteries waiting to be solved. What other secrets are hiding in the dark? Are there comets that have been captured by other planets, becoming new moons? Are there rogue planets wandering alone between the stars? What will we find when we finally send a probe to explore the strange worlds orbiting Alpha Centauri? The questions are endless, and that's the best part. There will always be something new to discover, something new to wonder about. So, I invite you to keep looking up, keep asking questions, stay curious. The universe is the greatest story ever told, and it's still being written. You are part of that story. What will your chapter be? The next time you see a shooting star, which might just be a tiny piece of a long-dead comet, make a wish, but also think about the incredible journey that little piece of dust has taken to get to you. The cosmos is calling. Go explore. If you enjoyed this cosmic journey, don't forget to like this video, subscribe to the channel for more science adventures, and share it with a friend. And let me know in the comments, what is the biggest mystery in the universe that you want to see solved? The adventure continues, and the universe is waiting for you.